Ever find yourself grappling with a big philosophical question like, what can we really know about the world, especially when science starts talking about things we can't even see?
Oh, yeah, definitely. Especially when you're trying to wrap your head around those really big ideas that science throws at us. Like, sure, we see the results, but what's really going on?
Exactly. And today we're diving into one perspective on that very question, a viewpoint in the philosophy of science called constructive empiricism.
And to help us explore this, you, our amazing listener, sent us to a great resource, the Stanford Encyclopedia of Philosophy, entry on constructive empiricism.
Perfect. So, in this deep dive, we're going to unpack the core of this view, why it matters, and the main philosophical arguments surrounding it.
We'll try and give you a clear picture of what this all means without getting too bogged down in, philosophical jargon.
Sounds good to me. So, let's start simple. What is constructive empiricism? What's the basic idea?
Well, at its heart, it's a view about the aim of science.
Okay, the aim. So, not just what individual scientists might be trying to do, but like the goal of the whole scientific enterprise.
Exactly. And the key figure here is Bos van Frassen. He's the one who really developed this view.
Yeah.
And he famously said, "Science aims to give us theories which are empirically adequate. And acceptance of a theory involves as belief only that it is empirically adequate."
All right, so there's a lot to unpack there, but that phrase, empirically adequate, definitely seems key.
Yeah, it's really the core of the whole thing. Basically, it means that a theory is successful if what it says about the observable parts of the world is true.
So it's not about denying the existence of things we can't observe, just saying that science isn't necessarily in the business of proving they exist.
Right. It contrasts with a more, let's say, ambitious view called scientific realism.
And scientific realism says?
Realists think science aims to give us a completely true story of the world, including all those unobservable entities and processes, like, the inner workings of atoms or the beginning of the universe.
So accepting a theory, for a realist, means believing the whole thing is true, unobservable parts and all.
Yeah, pretty much. But constructive empiricists are a bit more cautious. They're not saying those unobservable things don't exist, just that our belief, as informed by science, should only go as far as what we can actually observe.
So it's not about rejecting scientific theories, just interpreting them differently.
Exactly. And here's another important point. When constructive empiricists say a theory is empirically adequate, they're still understanding the theory literally.
Oh, that's interesting. You mean they're not saying it's just a useful metaphor or anything like that?
Right. So if theory says electrons exist, they take that as a real claim, which could be true or false. But they're saying that science can only tell us whether that claim is empirically true or false, meaning whether it matches up with what we could observe.
So it's about how we justify our beliefs about the world based on what we can actually verify through observation.
Yeah, that's a good way to put it. And this distinguishes constructive empiricism from other views, like some forms of logical positivism or instrumentalism.
Which,
Well, some of those views suggested that we should only talk about things we can directly observe, or that scientific theories are just tools for prediction without any real claim to truth.
but constructive empiricism is different.
Yeah, they're not trying to eliminate talk of unobservable things. They're just saying that science can't give us definitive proof about them.
Okay, so that focus on the aim of science is really central to this view. Can you say a bit more about why that matters so much?
Sure, it gets to the heart of what constructive empiricism is actually trying to do. It's not primarily a guide for how individual scientists should think or feel. Instead, it's about what we should consider success in science at a kind of philosophical level.
I see. So it's not telling scientists to stop believing in quarks or black holes. It's about what standards we use to judge the success of scientific theories.
Precisely. Van Frassen even distinguishes between what he calls scientific agnostics and scientific gnostics.
Okay, those are interesting terms. What's the difference?
A scientific agnostic is someone who believes that a successful theory is empirically adequate, but they don't necessarily believe that it's true beyond that.
Yeah.
They might even be skeptical about whether we can ever know the truth about unobservables.
So kind of like, I accept that the theory works, but I don't necessarily buy into the whole picture it paints of reality.
Yeah, something like that. On the other hand, a scientific gnostic is someone who does believe that the accepted science is true, including its claims about unobservable things. They think science can give us real knowledge about those things.
So are constructive empiricists always scientific agnostics?
Not necessarily. A constructive empiricist can be a scientific gnostic in their personal beliefs. They might even think that some scientific theories are very likely to be true. But when it comes to what counts as success in science, they still hold that the main goal is empirical adequacy.
That's an interesting distinction. So it's possible to believe in the truth of a theory while also accepting that the aim of science as a whole might be more limited.
Exactly. That's a subtle point that often gets missed.
Okay, so we're getting a clearer picture of what constructive empiricism is all about. But we keep coming back to this idea of empirical adequacy. Can you unpack that a bit more? What does it actually mean for a theory to be empirically adequate?
Sure. So, in a nutshell, it means that everything the theory says about observable phenomena is true.
Okay, simple enough. But how do we know what's observable?
That's a crucial question, and we'll get to it soon, I promise. But for now, let's stick with this idea of empirical adequacy. It's not just about explaining things we've already observed. A truly empirically adequate theory should also be able to predict future observations.
So it's not just about fitting the data we already have, it's about being able to make accurate predictions about what we'll observe in the future.
Exactly. That's a really important part of it.
Mm.
And Van Frassen gives a more formal account of empirical adequacy based on his semantic view of theories.
Semantic view. Okay, that sounds a bit technical. What does that mean?
Basically, it means he sees theories as more than just sets of sentences. He thinks of them as families of structures or models. And within these models, there are specific parts he calls empirical substructures.
Empirical substructures. Okay, let's break that down.
Sure. Imagine all the things we can observe and measure in the world. The data we collect in experiments, the things we see through telescopes, all that stuff. That has a certain structure to it.
Right. Yeah, I guess so.
Well, a theory is empirically adequate if that structure of observable phenomena can be perfectly matched, what we call isomorphic, to the empirical substructures of at least one of the theory's models.
Isomorphic, meaning like a perfect fit or mapping.
Yeah, exactly. Think of it like the pattern of the observable world fits perfectly into a pattern offered by the theory.
Okay, I think I'm starting to get it. So believing a theory is empirically adequate doesn't mean believing that the whole theory is a perfect mirror of reality, just that the observable parts fit.
Exactly. And this is how Van Frassen addresses a common worry about the observable and observable distinction.
Which is?
The worry is that if you believe in the observable parts of a theory, you're already committed to believing in the unobservable parts too. Like if you believe in tables and chairs, you're already committed to believing in atoms, even though you can't see them.
Right, because the theory says that tables and chairs are made of atoms.
Exactly. But Van Frassen says that belief in empirical adequacy is just about the possibility of embedding the observable phenomena within a theoretical structure. You're not committed to the truth of claims about the unobservable parts of that structure.
So it's about the fit, not about believing in every detail of the picture.
Precisely. And that's why the focus on the aim of science is so important. It's not about saying what individual scientists should believe. It's about what we consider success in science itself. And for the constructive empiricist, success is achieving empirical adequacy.
Okay, so this idea of empirical adequacy is clearly doing a lot of heavy lifting here. Now, you mentioned earlier that we need to talk about what counts as observable. Why is that distinction so important for this view?
It's absolutely crucial because the whole idea of empirical adequacy rests on it. If we can't tell what's observable, we can't judge whether a theory is empirically adequate or not.
Right, makes sense. But defining what's observable doesn't seem straightforward at all.
No, it's definitely one of the most debated aspects of this whole view.
So what's the constructive empiricist take on it? Where do they draw the line?
Well, Van Frassen suggests a kind of rule of thumb. Something is observable if, under the right circumstances, if it were present to us, we could observe it with our unaided senses.
So what we can see, hear, touch, taste, smell, without needing any special instruments.
Pretty much, yeah. But he emphasizes that this isn't meant to be some strict definition, more like a general guideline.
Okay, but what about things we need instruments to see, like bacteria or distant galaxies? Are those observable?
That's where things get tricky. For the constructive empiricist, those things are typically considered unobservable. You're not seeing the bacteria or the galaxy directly. You're seeing an image produced by the instrument.
So the image is observable, but the thing itself isn't.
Right, and this is a major point of difference with scientific realists. They'd say that those images give us direct evidence for the existence of those unobservable things. But the constructive empiricist is more cautious. They'd say the image is just a phenomenon we need to explain, and the theory might offer an explanation in terms of bacteria or galaxies, but we don't have to take that as literal truth.
I see. So it's about the level of directness of our experience.
Yeah, that's a big part of it. And it gets even more complex when you consider that our understanding of what's observable can itself be influenced by our scientific theories.
So science helps us define what we consider observable, but then we use observation to judge science. Isn't that circular?
That's a valid concern, and we'll get to some of those criticisms later. But for now, the main takeaway is that for the constructive empiricist, observability is closely tied to our human sensory capabilities, and it's not some fixed, absolute category.
It's evolving along with our scientific understanding.
Right. And that's one of the reasons why this view is so interesting. It forces us to think hard about the relationship between science, observation, and our beliefs about the world.
All right, so we've got a theory that's aiming for empirical adequacy, meaning getting the observable stuff right. And accepting a theory involves believing in that empirical adequacy, not necessarily in its complete truth. But why would anyone accept a theory under this view? What does that acceptance really mean?
Good question. Acceptance, for the constructive empiricist, has two main components, an epistemic one and a pragmatic one.
Okay, so the intellectual side of it and the practical side of it.
Yeah, exactly. The epistemic side is about belief. So, you believe that the theory is empirically adequate. That means you think it gets the observable stuff right, and you're willing to trust its predictions about future observations.
So it's a kind of trust in the theory's ability to accurately describe and predict the observable world.
Exactly. But there's also a pragmatic side to acceptance. And this part is about how we use the theory.
Like how we apply it in research and stuff.
Yeah, and even more broadly than that, it's about committing to using the theory's framework to understand the world, to try and explain new phenomena within its framework.
So it's not just about passively believing it, it's about actively using it as a tool to make sense of things.
Exactly. And this is a crucial part of why constructive empiricists think it's okay to talk as if a theory is true, even if we don't fully believe in its unobservable parts.
So like when scientists talk about black holes or quarks, they're not necessarily saying they know those things exist in the way the theory describes, but they're using that language to make sense of the data and make predictions.
Right. They're working within the framework of a highly successful theory.
Hmm.
And that framework gives them the tools to make progress, even if they don't buy into the whole metaphysical picture it paints.
That makes sense. It's like using a map to navigate a city, even if you don't believe the map is a perfectly accurate representation of every detail of the city.
That's a great analogy. The map is a tool, and it helps you get around, even if it's not completely true in every respect.
I like that. So we've explored what constructive empiricism is all about. Now let's dive into the philosophical arguments. What are some of the strongest reasons why someone might accept this view, especially if they're coming from a philosophical perspective?
Well, one of the most compelling arguments is based on a kind of epistemic humility.
Epistemic humility. You mean being modest about what we can actually know?
Exactly. The argument is that believing a theory is empirically adequate is a weaker claim than believing it's completely true.
Okay, so it's a less risky bet, epistemically speaking.
Exactly. You're not committing yourself to all those potentially unverifiable claims about unobservable things. You're just saying, look, this theory works really well in explaining and predicting what we can observe, so let's accept that much.
It's like saying, I'm not going to go out on a limb and say I know everything about reality, but I'm confident that this theory gets the observable stuff right.
Right. And Van Frassen has this great quote, he says, "It is not an epistemological principle that one might as well hang for a sheep as for a lamb."
So don't take on more epistemic risk than you need to.
Exactly. If believing in empirical adequacy is enough to make sense of science, why go further and risk being wrong about all that unobservable stuff?
That's a good point. What other arguments are there in favor of constructive empiricism?
Another key one has to do with the relationship between theory and experiment.
Okay, so how this view sees the interplay between those two things.
Right. Scientific realists often see experiments as tests of a theory's truth. Like, we design experiments to figure out whether the theory's claims about the unobservable world are actually correct.
But constructive empiricists have a different take.
Yeah, they see things a bit differently. They think theories are primarily tools that guide our experimentation in the observable world.
So the theory helps us design experiments that reveal more about the observable world.
Exactly. It helps us discover patterns and regularities in what we can observe. But it's not necessarily giving us a true picture of some underlying, unobservable reality.
So it's more like a map than a photograph. It helps us navigate the observable world without necessarily showing us what's really there.
Yeah, I think that's a good way to put it. And Van Frassen uses a classic example to illustrate this point, Millikan's oil drop experiment.
The one that's often cited as evidence for the existence of electrons.
That's the one. Realists see that experiment as determining the charge of an electron, an unobservable particle. But constructive empiricists interpret it differently. They say it's more about filling in a value for a parameter within a theory. It's revealing an observable regularity related to charge and force, but it's not necessarily proving that electrons exist in the way the theory describes.
So the experiment is successful because it gives us more precise information about the observable world, not because it reveals the truth about some unobservable entity.
Exactly. And Van Frassen has another great quote about this. He says, experimentation is the continuation of theory construction by other means.
I like that. It suggests that theory and experiment are both part of the same process of building up our understanding of the world.
And for the constructive empiricist, that process is ultimately aimed at achieving empirical adequacy, not necessarily at uncovering the ultimate truth about reality.
Okay, that makes sense. What other arguments do constructive empiricists make in favor of their view?
Another one has to do with the pragmatics of theory choice.
Pragmatics. You mean like the practical considerations that go into choosing one theory over another?
Exactly. So when scientists are faced with multiple theories that all seem to fit the data, they don't just pick the one they think is most likely to be true. They also consider things like simplicity, elegance, scope, explanatory power, all those kinds of things.
Right, so it's not just about finding the theory that's most likely to be a perfect reflection of reality. It's about finding the theory that's most useful for doing science.
Precisely. And constructive empiricists argue that these criteria for theory choice are primarily pragmatic virtues. They're helpful for guiding our scientific work, but they're not necessarily reliable indicators of truth, especially truth about unobservables.
So a simpler theory might be easier to work with, but that doesn't necessarily mean it's more likely to be true.
That's the idea. And it applies to other criteria too, like explanatory power.
Okay, but realists would say that the theory that provides the best explanation is probably the true one, right?
Yeah, that's a common argument. But constructive empiricists have a different view of explanation.
How so?
They see explanation as a pragmatic affair, meaning it's highly dependent on context and the specific question being asked. A theory explains something by providing information that's relevant and informative in that particular context.
So the same theory might provide different explanations depending on the situation.
Exactly. And they argue that a theory can be empirically adequate and provide excellent explanations without necessarily being literally true about the unobservable.
So we might have a really good explanation of a phenomenon even if the underlying picture of reality offered by the theory is wrong.
That's their position.
hmm
And they point out that explanations often involve things like causal claims and counterfactuals, and the truth of those can be very context-dependent.
Counterfactuals, meaning what would have happened if things were different?
Right. So, for example, if I say, if I hadn't tripped, I would have spilled my coffee, that statement's truth depends on a whole bunch of background assumptions, like, was the coffee hot? Was I holding it carefully? All those things factor into whether the statement is true.
I see. So for the constructive empiricist, explanation is more about providing useful information within a specific context, rather than uncovering some objective truth about causation or the laws of nature.
Exactly. And they argue that this view helps us avoid getting bogged down in all sorts of metaphysical debates about the nature of causation and the unobservable world. They want to keep things focused on the observable and on the practical goals of science.
They're trying to ground science in what we can actually experience without making all these extra assumptions about what's really going on behind the scenes.
Exactly. And they'd say that this approach is more in line with the spirit of empiricism, which emphasizes the role of experience in shaping our knowledge.
All right, so those are some of the main arguments for constructive empiricism. But I know there are also some strong criticisms of this view. Where do the realists and others push back?
Oh yeah, there are plenty of objections, and they come from all different angles. One of the most famous is the no miracles argument, sometimes called the miracle argument.
And this argument says,
Basically, it says that the incredible success of science would be a miracle if our theories weren't at least approximately true. Like, how could we make such accurate predictions and explanations if our theories weren't getting something right about the unobservable world?
that's a pretty intuitive objection. If a theory works really well, it seems like it must be tapping into some underlying truth about reality.
It's a powerful intuition, But Van Frassen has a response to this. He offers an analogy with natural selection.
Natural selection, like in evolution.
Right. He says that the development of scientific theories is kind of like the evolution of organisms. We come up with all sorts of theories, but only the ones that are empirically adequate. The ones that work survive the competition. Just like organisms that are well adapted to their environment thrive, theories that accurately describe the observable world persist.
So the success of our theories isn't a miracle, it's the result of a kind of selection process. Only the fittest theories survive.
Exactly. And just like a moth that's well camouflaged can survive without understanding the complex principles of genetics, an empirically adequate theory can be successful without being literally true about the unobservable.
So we don't have to appeal to truth to explain the success of science. We can appeal to this idea of empirical fitness.
That's the idea. And it's a powerful response to the no miracles argument. But there are other objections too.
Like what?
Another big one is the argument from inference to the best explanation, or IBE for short.
IBE. Remind me how that one goes.
Sure. The basic idea is that if we have multiple explanations for something, and one of them is clearly the best, then we have good reason to believe that the best explanation is true.
Okay, that makes sense. So if we have a theory that provides a really elegant and comprehensive explanation of a bunch of phenomena, it seems like we should infer that the theory is probably true, even if it involves unobservable entities.
That's the realist argument, yeah. But constructive empiricists have several responses to this.
Oh, okay, let's hear them.
Well, first, they question whether scientists actually use IBE all that much. They might argue that scientists are more concerned with finding empirically adequate theories, regardless of whether they provide the best explanation in some absolute sense.
So it's more about finding a theory that works, even if it's not the most elegant or philosophically satisfying explanation.
Right. And second, they say that even if we grant that IBE is a legitimate form of reasoning, it doesn't automatically lead us to belief in the truth of a theory. It might only lead us to believe that the theory is empirically adequate.
So even if we accept the best explanation, we might not be justified in believing the whole theory is true, just the parts that deal with the observable world.
Exactly. And third, they point out that we might not even have the right set of explanations to choose from. The best explanation we have right now might still be wrong, and there might be a better explanation out there that we haven't thought of yet.
So we should be cautious about inferring truth from the best explanation because we might not even have the full picture yet.
Exactly. And finally, some constructive empiricists argue that IBE itself is problematic. They point out that there are different ways to formulate IBE, and some of those formulations lead to logical inconsistencies.
Okay, so they're not just saying IBE doesn't support realism, they're saying it might not even be a valid form of reasoning in the first place.
Right. And all of this is to say that the argument from IBE is far from a slam dunk for the realists.
I see. Now, we've talked a lot about the unobservable distinction and how crucial it is for constructive empiricism. But I imagine that's also a major target for criticism, right?
Oh, absolutely. It's probably the most controversial part of the whole view, and there are tons of objections to it.
Like what?
Well, some philosophers, like Paul Churchland, have argued that the distinction is just too vague and arbitrary. He questions why our current human limitations should define what's fundamentally observable. Like, why should the fact that we can't see atoms with our naked eyes mean that atoms are unobservable in some absolute sense?
Right. Maybe there are other beings out there who can see atoms, or maybe we'll develop technology that allows us to see them in the future.
Exactly. And Churchland even uses thought experiments to make this point. Like, he imagines a species of humanoids who have built-in electron microscopes in their eyes.
So for them, atoms would be observable.
Right. And he argues that this shows that the observable-unobservable distinction is just a matter of our contingent biological makeup, not some deep philosophical divide.
Okay, so that's a challenge to the idea that the distinction is meaningful in some objective sense. How do constructive empiricists respond to that?
Well, Van Frassen would say that the distinction isn't meant to be about some metaphysical difference in the world. It's about our epistemic access to the world.
Epistemic access, meaning what we can know about the world.
Exactly. So the fact that we can't see atoms with our naked eyes isn't some deep fact about atoms. It's a fact about our human sensory capabilities. And those capabilities shape what we can know about the world.
So it's not that atoms are inherently unobservable, it's that they're unobservable to us, given our current limitations.
Right. And regarding those electron microscope humanoids, he might say that their experiences wouldn't count as observations unless we considered them part of our epistemic community.
Meaning we'd have to accept their way of perceiving the world as a valid form of observation, which would require some shared understanding of what constitutes observation in the first place.
Exactly. But even then, he'd probably still argue that there's a difference between observing something directly with our senses and observing it through an instrument.
Okay, so that's one response to Churchill's objection. What about other challenges to the unobservable distinction?
Well, another influential critic is Ian Hacking. He's done a lot of work on the history and philosophy of microscopy.
And his argument is,
Basically, he argues that our ability to manipulate and even manufacture microscopic objects gives us strong reasons to believe in their reality, even if we can't see them directly.
so like if we can build a tiny machine out of atoms, that suggests that atoms must be real, right?
That's the idea. And he also points out that we get consistent images of microscopic objects across different types of microscopes. Like if we look at a cell under an optical microscope and then under an electron microscope, we see basically the same thing.
And that consistency suggests that we're really seeing something that's there, not just an artifact of the instrument.
Right. And Hacking argues that this kind of consistency wouldn't be possible if the microscopic world wasn't real.
Okay, so that's a pretty strong argument. How does Van Frassen respond to that?
He's got a couple of moves here. First, he points out that Hacking's argument sometimes assumes the very thing it's trying to prove.
Like, it assumes that the microscopic objects were actually created in the way we intended.
Exactly. Like,
Huh.
if we build a tiny machine and it works, we assume that the atoms were arranged in the way we designed them. But Van Frassen would say that's already assuming the theory of atoms is true.
So it's circular reasoning.
Kind of, yeah. And second, he challenges the idea that persistent similarities across different observations always require a true explanation.
So we might have consistent observations even if the underlying explanation is wrong.
That's what he's suggesting. He thinks it's possible to have consistent but ultimately inaccurate accounts of the world. And he uses analogies to make this point.
What kind of analogies?
Well, one analogy he uses is with reflections. He points out that when we see a tree in a mirror, we say we're seeing the tree, even though what we're actually seeing is a reflection. And he argues that observation through a microscope is kind of similar. We're not seeing the object directly, we're seeing an image that's mediated by the instrument.
So it's not a direct perception of the object itself, it's more like seeing a representation of the object.
Right. And he also distinguishes between unaided observation, where we can often find independently observable invariances, and instrument-mediated observation, where those invariances are lacking.
Invariances, meaning like consistent patterns or regularities that we can observe across different contexts.
Yeah, exactly.
Yeah.
So, for example, we can observe that a tree casts a shadow, and the shape of the shadow changes in predictable ways, depending on the position of the sun. That's an invariance that we could observe without needing any instruments. But for microscopic objects, those independent confirmations are often missing.
So it's harder to be sure that we're really seeing something that's there rather than just an artifact of the instrument.
Right. And Vilfrassen even suggests thinking of microscopic images as being kind of like rainbows.
Rainbows.
Yeah, he says they're both public phenomena that don't correspond to a concrete object at a specific location in the same way that a tree does. We can all see a rainbow, but there's not actually a physical object at the end of the rainbow.
I see. So he's saying that microscopic images might be more like representations or projections than direct perceptions of real objects?
That's one way to interpret his view. But there are other challenges to the observable-unobservable distinction, too. Like some philosophers have argued that even our unaided perception involves a kind of image-like representation in our minds.
So even when we're not using instruments, we're still not directly perceiving the world.
That's the argument. It gets pretty deep into the philosophy of perception. But the basic idea is that there's always some level of mediation between our minds and the world. We're not just passively receiving sense data, we're actively interpreting it and constructing a picture of the world.
And that challenges the idea that there's a clear line between what's observable and what's not.
Exactly. It blurs the boundaries a bit. But constructive empiricists have responses to this too. They might argue that even if there's some level of mediation in all perception, there's still a difference between the kind of mediation that happens in unaided perception and the kind that happens in instrument-mediated perception.
So they're not denying that all perception is constructive, but they're saying that instrument-mediated perception is more heavily reliant on theoretical assumptions.
Right. And that makes it harder to justify beliefs about the unobservable world based on those kinds of observations.
Right. Okay, so it seems like this debate about the observable unobservable distinction is really at the heart of the disagreement between constructive empiricists and scientific realists.
Definitely. It's a key point of contention. And there are lots of other criticisms of constructive empiricism, too. Like some people have argued that it's not actually as modest as it claims to be.
How so?
Well, constructive empiricism says we should only believe in what's observable. But some critics say that's still too strong. They argue that we should only believe in what we've actually observed.
So not just things that we could observe in principle, but things that someone somewhere has actually observed.
Exactly. And they point out that there are lots of things that are observable in principle, but that no one has ever actually observed.
Like what?
Well, for example, there might be a specific kind of butterfly that lives in a remote part of the rainforest that no one has ever seen. It's observable in principle because if someone were to go to that part of the rainforest, they could observe it. But no one has actually observed it yet.
I see. So these critics are saying that constructive empiricism is still going beyond the evidence by claiming we can believe in things that are observable but haven't actually been observed.
Right, and they argue that this is a form of unwarranted speculation.
Okay, that's a fair point. How do constructive empiricists respond to that?
They argue that if we limited science to just describing what's already been